Concrete. Highway construction calls for a lot of it, and it has to be high-quality material. If you could take the concrete out of this structure, what you'd have left would be basically a lot of reinforcing steel. From the bottom up, it's concrete. Piling, footings, columns, caps, beams, deck, and railing. We use concrete extensively. In bridges, of course, but also in pavement, culverts, barriers, and retaining walls, and the list goes on. Because of the various uses for concrete, there are different classes of the material. Each class of concrete is based on a different design. That's why testing is necessary, to make sure that the mix required by the specifications is delivered to the job site, and to make sure that the concrete is mixed consistently. A problem at the plant will show up in the field test results. That is why the inspector's on the job, to make sure the department gets the quality it pays for. Here are the major tests: temperature, slump, compressive strength, and air content. This program, Field Testing Concrete, Part 1, covers the necessary preparations, sampling concrete, and checking temperature. Part 2 covers testing the concrete for slump and casting and testing cylinders for compressive strength. And Part 3 deals with the air content test. The whole course is based on the department's GHDs and GSPs found in the Sampling, Testing, and Inspection Manual and the standard and supplemental specifications. The manual outlines the procedures to follow, the testing frequencies, and test results required for acceptance. You'll refer to the manual often when you're on the project, so a copy should always be available for reference. Okay, let's get going. Preparations. But first, a couple of quick notes. Before the work begins, check the specs and the contract item description. Discuss the procedure for sampling and testing with the contractor's representative. Make sure there is an understanding about the timing and methods of obtaining samples and running tests. Okay, before any concrete is delivered to the work site, make sure you're ready for it. For example, if you're patching, is the base well compacted, stable? Are the forms and reinforcing bars in place? If the job is really well coordinated, the concrete will be placed as soon as the truck arrives. So check the job site and the testing equipment. You'll be running slump test and air content test and casting cylinders. So make sure the equipment's on hand, in good shape, relatively clean. And for air content test, make sure the meter has been calibrated recently. When each truck arrives, collect the delivery ticket from the driver. That's your verification that the correct concrete design is being mixed. Check the class of concrete and the water-cement ratio. Then double-check the class of concrete. Save the delivery tickets. They're part of the project documentation. The delivery ticket shows the amount of concrete in the truck, the time at which it was batched, the reading on the truck's revolution counter, and the total number of gallons of water withheld. Water can be added later, but only up to the number of gallons that were withheld at the plant. The time is critical. Concrete must be placed within 60 minutes after mixing. So if the concrete was batched at 2 o'clock, it must be placed by 3 o'clock. The revolution counter on the truck records each revolution of the drum at both mixing and agitating speeds. The concrete will lose its workability if it's mixed too much, so it's important to keep an eye on the counter. The counter reading on the delivery ticket was taken when the concrete started mixing, if it was truck mixed, or when the concrete was placed in the truck, if it was plant mixed. Before the concrete is placed, read the counter, and read it again at the completion of the discharge. Then record the total revolutions on the delivery ticket. If it's truck mixed concrete, it has to be mixed between 70 and 150 revolutions at mixing speed, and no more than 300 total revolutions, counting both mixing and agitating revolutions. If it's plant mixed concrete, there are mixing time limits for the central mixer, but the same 300 total revolutions limit applies for the hauling units, whether they're truck mixers or agitators. Okay, that covers preparations. Make sure the work site is ready. Check the testing equipment. It should be in good shape and recently calibrated. Get all of the delivery tickets. For each truckload, make some records on the delivery ticket. The truck number, the cubic yards of concrete delivered, the total mixing water added, and the total revolutions. All test results go onto the delivery ticket too, but we'll cover that later on. Now, on to sampling. The procedure for getting a sample of concrete to run the tests is covered by GSP 17. Actually, the word sample isn't quite enough. What you're going for is a representative sample. You want to make sure the concrete that you're testing is typical of the entire truckload. The basic rule in sampling concrete is this: don't take the sample from the beginning or the end of the discharge. It's best to take it from the first 1/3 of the discharge, but never from the first 2 cubic feet. So when the concrete first starts to flow, let it run until you figure that at least 2 cubic feet have gone by. That's about half a wheelbarrow's worth. Then it's okay to sample the concrete, either by catching the entire stream in a container or by swinging the chute over to the side. The important point is this: get the entire stream. Cutting the stream in half, like this, is unacceptable. The rim of the bucket will knock some of the large aggregate out of the sample. Remember, a reliable test calls for a representative sample. The sample should be mixed with a shovel, just enough to give it a uniform appearance. Then it should be covered to protect it from the sun and the wind. Don't let it dry out. One last point in sampling: check the time. You have only 15 minutes to complete the testing and cast the cylinders, if they're going to be made from this load. And that covers sampling. Now, temperature. Temperature affects concrete the same as it affects people. It can freeze and it can overheat. Neither is acceptable. In concrete work, temperature is always a concern, both the air temperature and the temperature of the concrete. Of course, the air temperature affects the concrete temperature, and the concrete can't withstand extreme highs or lows. In general, the concrete temperature has to be between 50 and 90 degrees Fahrenheit. And the air temperature determines whether to use normal curing procedures or special cold weather curing. Checking the concrete temperature is simple. Just insert an approved thermometer into the sample. Wait a minute or so, then read it. Record this reading and the air temperature on the delivery ticket. There are several variations in the requirements depending on the type of concrete and the job you're working on. The department's specs, the sampling, testing, and inspection manual, and the project plans are your best guides. Check them for each project. And that completes part 1 of the series on concrete sampling and testing. Preparations, sampling, and checking temperature. When you're ready, go on to parts 2 and 3.
Field Testing Concrete, Part 2. This program covers the slump test and the compression test. We'll start with the slump test. Basically, the slump test consists of filling a standard slump cone with concrete, rodding it to consolidate the concrete, then lifting the cone off, and measuring how far the concrete slumps down when it's not supported by the cone. The slump test is a measure of two things, uniformity and consistency, and it indicates how workable the concrete is, whether it's relatively stiff or more fluid. Here are two examples with different slumps. It's a bit confusing to beginners, but you'd refer to the one on the left as having a high slump. The one on the right has a low slump. When you think about it, it makes sense. The concrete on the left slumped farther, so it has a high slump measurement. The procedure that you'll see here is based on GHD 27, contained in the Sampling, Testing, and Inspection Manual. Read it. Become familiar with it. The GHDs cover the procedures and the equipment used. To run a slump test, you need, first, a rigid, stable base that won't absorb water from the concrete sample. A wet piece of plywood is fine. Just make sure there's no freestanding water on it, because that would affect the concrete. Second, a standard slump cone. It should be reasonably clean with no major dents. Make sure the inside is smooth. No dried concrete. Third, the tamping rod. Make sure it's the standard rod made for concrete testing. It's not acceptable to use a cut-off reinforcing bar instead. The bar has to have a rounded tip so that the large aggregates aren't pushed to the bottom when the concrete is being rodded. Next, a scoop. The kind with the rounded bottom is best because it makes it easier to get the concrete into the cone. And finally, something to measure the slump with, a ruler or measuring tape. And that's all the equipment you need: the base, the cone, the rod, a scoop, and a ruler. Now for the test procedure. To begin with, of course, you need a sample, remixed until it looks uniform. Dampen the inside of the slump cone so the concrete won't stick to it. And dampen the base as well. But remember, no freestanding water. Place the cone down on the base as close as possible to the concrete sample. Make sure the base is level and firmly supported. It has to be flat and stable. That's a must. The person doing the test should step onto the footholds at the bottom to hold the cone steady and stay there. That's why the cone should be close to the concrete sample. Now he can start filling the cone. It's best to move the scoop around the top to get the concrete distributed as evenly as possible. The cone is filled and rodded in layers by volume, not according to the height of the cone. The first layer should come up about 2.5 inches. The second layer should come up about 6 inches, about halfway up the cone.